Picture a computer so powerful it can solve problems no normal chip could touch, but the weird part is that the computer itself barely uses any power. The real energy hog is the giant freezer wrapped around it. But the freeze isn't for storage, it's for keeping qubits cold enough to behave like perfect little quantum performers instead of noisy, panicked particles. This leads to the strangest truth in quantum hardware. The actual computing signals flowing through a superconducting quantum chip are so tiny they use less power than a single LED nightlight. Yet the dilution refrigerator, keeping everything cold, can burn through thousands of watts just to hold the temperature steady. Which means the machine does almost no electrical work, but it demands a massive river of energy to stop the qubits from falling apart. And that contrast shapes everything about how these systems evolve. Because engineers aren't fighting to feed qubits more power, they're fighting to make them colder, calmer, and less needy. So every improvement comes from shrinking the freezer, softening vibrations, shortening cables, and cutting microscopic heat leaks that would never matter in any normal computer. Which means the real frontier of quantum hardware isn't how much power the processor can handle, it's how close we can get to absolute quiet in a world that's always shaking, glowing, and warming everything it touches. And that's why the future of quantum computing looks less like a blazing supercomputer and more like a high-tech ice cave, desperately protecting a tiny island of perfect order. And if that contrast blows your mind as much as it did mine, stick around for more stories like this.